So that's good. Hello everybody. And let's do this register. So who we got? So that's is that Joan or George at the top there? I think that's Joan. Yeah, that's Joan. Cool. All right. So Joan present, Callum present, Roddy present, Alex present, Fifi, Becca, Sophie. Cool. Any Caleb, Charlie, George say yeah. Leo. Anyone heard from those three? Caleb, hey, cool. So does Charlie and Leo. Cool. All right, let's get started. So yesterday we got up to the vectors question. No, you didn't. Caleb, I've ticked you off. Hello. Yeah, vectors question, and we're gonna move on today to whatever comes next. I can't remember what question number that was actually. That was number 5. Cool. So question 6. Can't remember quite where I saved this paper. There. Okay. Oh, okay then. Can that fit on the screen? Yeah, just about. All right, if you guys could try these two. We're talking how many marks? 8, 10, 14 marks here. So yeah, 14 marks worth. So we got an integral, which looks alright. And we got a sequence and series question. So yeah, I'll give you guys 14 minutes to do these. Timer starts now. I'm not sure why C is, well, Poppy is 3 marks. That seems very, very kind of them. Um, yeah, don't know. I would give that 2, but whatever. It's 1 mark difference. And yeah, it says X5. Thank you, Roddy. Cool. Right, guys. Hopefully that was okay. Let's give it a go. So, first one, we are talking integration. So, what rule did you guys use for this then? Anybody recognize what to do? So, the trick here is spotting that you've got f dash x over f of x. We're going to try ln of e to the 2x minus 1. So we need to check that. So if we differentiate that, we would get 2 e to the 2x on top over e to the 2x minus 1. So we in fact need to have a half of our answer. So our answer is going to be a half ln e to the 2x take 1, square brackets, limits, ln 2 and ln b. Cool. Yep. Well done, Callum. Cool. Okay, so we need to put our limits in. So we're going to get half ln e to the 2 ln b minus 1. Take half ln e to the 2 ln 2 take 1. So you get that. Now we want to use a couple log rules. So we're going to use the power rule and then get rid of these and the lns. And then use log division rule to simplify. So the first thing I'm going to look at is the powers there. So I'm going to use power rule within that power to get ln b squared. So half ln e to the ln b squared minus 1 minus half ln e to the ln 4 take 1. So use the power rule there twice. And now those e's and ln's are going to kind of undo each other. So we get half ln b squared take 1 minus half ln 4 take 1. Cool, getting somewhere now. We got a half, we can take that as a factor, then we can use the division rule on our two logs to turn this into, running out of space here, so let's delete some earlier stuff. So we can go half ln of b squared take 1 divided by 4 take 1 is 3 divided by 3. So we get that, and that equals ln 4. Cool. just to make things easier, I'm going to times both sides by 2. So we're going to get ln b squared take 1 over 3 equals 2 ln 4. Use the power rule again. Ln b squared take 1 over 3 equals ln 16. 4 squared is 16. And now I can get rid of the ln, so I can e both sides and get b squared take 1 over 3 equals 16. Times that by 3 plus 1 and then square root. So if we do that, we're going to get 48. Yes, 48. B squared take 1 is 48. So B squared is 49. So B equals 49 plus or minus 7. Cool. And we know it was a ln B was our limit. If you look back at the top, ln B, ln of minus 7 wouldn't work. So B has to equal 7. Cool. There you go. Not bad for 8 marks, really, as long as you can remember integration by recognition. Okay, second one then. So now we've got a sequence. So cool. We need to find x3. So we know x1 is 4. x2 is going to be p times x1 minus 9. So in other words, 4p take 9. Yeah, you still get the full marks if you got the answer correct. What method did you use then, Fifi? Have a quick comment. We'll come back to it in a second. So I found x2. We're going to put x2 back in to find x3. So x3 will be p lots of x2 take 9. And if we expand that, x3 is going to be 4p squared take 9p take 9. So nice and easy there. Okay, part B. We're told that x3 is 46. So we're going to set this equal to 46. 4p squared take 9p take 9 equals 46. Solve that quadratic and we get 5 or minus 11 over 2. 11 over 4 even. But it does say p is an integer, so we can't have that solution. Oops. Can't have that one. So p is 5. All right, last bit. Find x5. So if we put, well, we know x3 is 46, so our next value is going to be 5 lots of 46 take 9, which gives us 221. And then our next one is going to be 5 lots of 221 take 9, which gives us 1096. You use log laws on different bits. Yeah, that's fine. You can apply log laws in lots of different ways, so that's why. All right, so that's those two. Let's move on. So we've got partial fraction. Oh, is it partial fractions? No, I don't think it is. I think it's just some algebra, but we'll see what happens. So 4 marks. I'll give you guys 4 minutes to do this one. Cool, get going. Cool. Right, hopefully you guys got on right with that one. So with these ones, the trick is to start by factorizing, well, the one on the left, and hopefully we're going to find a common factor with the one on the right, and then the fraction should be pretty easy to add together. So let me get the timer out of the way. So we're going to factorize the denominator. So 6 over, so it'll be 2x plus 5, 2x take 1. Oops, plus 3x plus 1 over 2x minus 1. Okay, so you'll notice both of these have a common factor of 2x take 1. So if we get a common denominator of 2x plus 5 by timesing this fraction here by 2x plus 5 on top and the bottom, we can get a common denominator. So nope, did the wrong thing, wrote it wrong. 2x plus 5 there. And then we're going to add these fractions together to get 6 plus 3x plus 1, 2x plus 5 over 2x plus 5, 2x minus 1. Cool. So we have a single fraction. All we need to do now is simplify this. So we're going to expand the top and see if there's any factors we can cancel with the bottom. So 6 plus 6x squared plus 17x plus 5. Cool. Right, that might be it. We just need to see if we can factorize it. Does the top factorize? I don't think it does, no. And if you're not sure, you can use a discriminant on it or quadratic. Just solve on the calculator, see if you get any actual factors. But I think that's it for this one. All right, what's next on this paper? So that's that page done. All right. This looks all right. So a nice little transformation question. Hopefully that will appear on the screen. Nope, made it too big. How about now? Yes, just about. Cool. All right, if you guys could try that one, it's 9 marks, so 9 minutes, and clock starts now. Go, 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 go. Joseph, you're still in the still in the wrong one. This is my further maths group. You were meant to be in this lecture yesterday. Were you here yesterday? I can't remember. Um, yeah, yesterday, and then Thursday lecture 2 is the next time I see you. b is modulus of x. So that's going to reflect the positive x values in the y-axis. Yeah, remove the old stuff. So all it says is reflect the positive x stuff in the y-axis, getting rid of any old stuff that used to be on that side of the axis. Sorry, Roddy, was on my head. Yeah, so you reflect the positive x values in the y-axis. Well, first of all, delete the negative x values and then reflect the positive x stuff in the y-axis. All right. Um, Hopefully he's right. You can always have a play with the graphical calculator and try and get an idea for these anyway. So, the first one, modulus of Fx. So I'll do this in blue. This is going to reflect all the negative y values in the x-axis. There we go. And we ought to label these points as well. So this point here is going to be, this point here is going to be 5. And this point here is going to be 2, 6. There we go. So that's the first one. Next one, I'll leave that for a sec, is the one Roddy was asking about. So we're reflecting all the, so delete negative x and reflect positive x in y axis. So all of this stuff is gone. Completely gone. And all this stuff gets reflected. Oop. So this point here will be -2, -6. Cool. And the last one is a stretch and a translation. So we've got a vertical stretch times 2 and a horizontal translation of -3. Because remember, x always does the opposite to what it says. So it doesn't matter what order we do these in. I think I will go for translation first. So we're moving at -3. So all these points are going to move 3, well, that way for you guys. So the point at 2 is now going to be at -1. So you have a point there, -1, -6. This point here at 0, -5 is now going to be at -3, -5. I don't know why I'm writing these because we have to change it in a minute anyway. And this one's going to be at -7, 3. So, otherwise the shape's going to be the same. Something like that. Okay, and now we need to stretch it by a factor of 2. So I'm going to basically accentuate the peaks. I don't know, something like that. So this point here, -7, 6. This point here, -3, -10. And this one, -1, -12. So that's what you should be left with. Something like that, at least, anyway. Okay, anyone got any questions? Right, next one I think is a 1/x graph question. So yeah, let's try and do both of these, as long as you guys can see them on the screen. Not quite. Try that. Nope. Still missing the bottom part D. There we go. Right, yeah, could you guys try this one then? So, 2 questions. It's going to take a while, these. What have we got? 4, 5, 6, 7, 8, 10. 10, 15, 20 marks. Ooh, 20 minutes. What we got left? 12. Yeah, we'll go for 20 marks, 20 minutes. So, maybe less. I'll give you 18 minutes just to try and keep you on your feet. So, comment if you need help though. But yeah, see if you can get both of these done. 18 minutes. Okay, you need to. Yeah, okay, these are often difficult. You want to sketch 2 over x take 1. Basically, we're trying to solve when that equals 0. We could basically say it's the same as when 2 over x minus 1 equals e to the x. So if you sketch 2 over x take 1, you sketch e to the x, there'll be one solution if those two graphs cross in one place. So sketch those two graphs and see how many times they intersect. How do you mean just put it in the calculator to sketch it? You could sketch that graph and say that that graph has one root. Yeah, that would work. But people without calculators will find it harder to draw that. But yeah, you'd get away with that. Cool. All right. Hopefully you guys found that okay. What if time? So the first one here is by drawing a sketch, show that there is only one solution. So if we sketch this, we've got an e to the x graph. So let's just draw e to the x. One. And we'll draw 2 over x minus 1. So 2 over x minus 1 has an asymptote at 1 and 0. So we'll omit them there. You can see it only. Cool. Okay, yeah, so draw it out and you can see it only crosses in one place. So we've got the asymptote there at 1. This one crosses at 1 as well there. I don't think we need to label y. I think that's going to be 2 there. Yeah, so draw your sketch, only crosses in one place, and then say as well, you need to state this, it intersects, only one intersect, therefore one solution. So that's what we need to do for the first bit. Part B, show the equation gx equals 0 may be written in that form. So this is the whole iteration bit. So we're going to say 0 equals 2 over x take 1 minus e to the x. And the whole idea here is to try and rearrange it to get x equals. If we have a look at this, we can work out a rough version of the form. Right, I think then we want to times both. I'll get e to the x on one side. So if I do this over here, so we'll say e to the x equals 2 over x take 1. If we multiply both sides by x take 1, we can get e to the x times x minus e to the x equals 2. We can then try and yeah, okay. If we then add e to the x to each side, so we get x e to the xx equals 2 plus e to the x. If we then divide both sides by e to the x, we get x equals 2 over e to the x plus 1, which is I think what we're after. Yeah, and then just show that e to the x. We can write that as 2 x equals 2 e to the minus x plus 1, and then we put the little n there and the little n plus 1 there to get our iterative formula. Okay, finds 4 decimal places the value of 1, 2, 3, and 4. Okay, so we're just going to put 1.5 into our equation, and we get x1 is 1.4463, x2 1.4709, x3 1.4594, and x4 1.4647. So let's type them in, hit equals a few times, and work out what the value is. Okay, using that as a first approximation, apply Newton-Raphson to get g of x to find a second approximation giving us 40p. Okay, so we need to remember the Newton-Raphson equation, which is going to involve some differentiation. So that's why this one is now worth 4 marks. So we need to, we need to differentiate g. So g dash of x. So 2 over x minus 1. If we write that as 2 x take 1 to the power minus 1, we're going to get the minus comes down the front, so we get minus 2 x take 1 to the power of minus 2. Then e to the x stays as e to the x. So that's our derivative of that function. Then we need the Newton-Raphson equation, which is, have we got any room left? Xn plus 1 equals x n minus g of x n over g dash x n. So we're basically going to put what's off at 1.5. So we're going to get our first x value is 1.5. Take away. Put 1.5 into the original equation and write that here. Over. Put 1.5 into the differential equation and write that here. And what you should get is x1 is 1.5. Take away minus 0.4816 over minus 12.4816. And you should get x1 equals 1.461 to 4 decimal places. I can't remember if that kind of matches up with what we did just now. I already deleted it. Yeah, cool. So that's that one, numerical methods. Right, question 11. So we want to do a binomial expansion of that. Yeah, so this should be all right. So to binomial expand something like that, we need to write it as two terms next to each other. So we're going to get 1 plus x times by 1 minus 2x to the power minus a half. Now the first bracket's good, we can just use that. For the second bracket though, we need to yeah, so we can just what am I talking about? The first bracket is just, we can't expand it, it's to the power 1. If you tried expanding it, it wouldn't change. Second bracket we can just do because we got 1 plus nx. So remember our binomial equation, 1 plus x to the n. So on and so forth. So that's what we're going to be using. So keep it as 1 plus x there. This bracket is going to become 1 plus minus a half times minus 2x. We're going up to the x squared term, so one more term after this, plus minus a half minus 3 over 2 minus 2x squared over that should say 2. That's a stupid thing to do there. That should be 2 factorial divided by 2. So we should get to there. So we're going to simplify this, expand it all, and then get rid of any terms greater power than term x squared. Okay, so 1 plus x times by 1 plus x, and we got minus a half times, I'll just calculator, plus 3 over 2 x squared. So we're going to multiply out those two brackets. Giving us 1 plus x plus 3 over 2x squared plus x squared. And I don't need to worry about the last term because it's x cubed. So to simplify, we get 1 plus 2x plus 5 over 2 x squared as my expansion. Okay, state the range of values for which it's valid. Well, the first bracket would be valid for x is less than or equal to 1. The second bracket, we use minus 2, so we're going to get 2x is less than 1, so therefore x is less than 1 half. Okay, let's keep our expansion. Part C, show that when x is 1 over 100, the exact value that is that thing there. Cool. So we're going to get 1 plus 2 over 100 plus 5 over 2 times 1 over 100. No, we're not. That's part D I'm doing now. So yeah, we're going to get 1 plus 1 over 100 over the square root of 1 minus 2 over 100. So we need to simplify this and turn it into the thing they've got written there. What's the easiest way to go about this? Let's sort out the square root at the bottom first. So if I want to bring in a factor of, say, 100 into that. Well, no, let's do it properly. 1 plus 1 over 100 over the square root. 2 minus 2, 1 minus 2 over 100 will leave us with 98 over 100. And if we want to, I'm trying to think what the best way to do this is. We could pull out a tenth. We could square root 98 and write it as thirds. So root 98 will turn into 7 root 2. Yeah, I think that'll do. So we're going to get 1 plus 1 over 100 over 7 over 10 root 2. Okay, now 7 over 10 we don't really want to write like that, so I'm going to flip that fraction to make it, God, there's not enough room. Let's get rid of what we did already. To make it 10 over 7 times 1 plus 1 over 100. Now, we don't want to write root 2, we want to rationalize this really. So we're going to times the top and the bottom by root 2. So we get root 2 on top, and on the bottom, I'm going to get 2. Cool. We can simplify that even further to get 5 over 7, 1 plus 1 over 100 times root 2. Okay, 1 plus 1 over 100 is going to be 101 over 100. So 5 over 7 times 101 over 100 times root 2. This is almost there now. So 5 times 1 over 1. 5 times 101. Basically, looking at the answer and seeing where we're going, we've got 101 root 2 on top already. Now, I can see that we got 5 over 100. So I can divide the top by 5 to get 1 and the bottom by 5 to get 20. And 20 times 7 is 140. So that turns into that. All right, last bit. So substitute it in to get an approximation to root 2. So we're basically saying the thing that they just gave us is equal to 1 plus 2 lots of 1 over 100 plus 5 over 2 lots of 1 over 100 all squared. We want to approximate root 2, so I'm going to times this side by 140 over 101. So I get root 2 equals 140 over 101 times by 1 plus 2 lots of 1 over 100 plus 5 over 2 lots of 1 over 100 squared. Cool. And if you do that, you will get 1.41421, which is a pretty good approximation to root 2, if you can see it there. Cool. Right, we've got 9 minutes left. I think we'll try the next question, but we probably won't finish it today. So that's question 12. How much more we got left? Oh, we're pretty close to the end as well. We'll definitely finish it this week, which is good. Yeah, this isn't going to get done in 10 minutes. So if you guys want to copy this down and you can start it, this is what we'll be starting with on Thursday. Yeah. All right, well, we'll leave that there. We'll end it for today. But have you guys got any questions or any topics you want me to go over quickly? Because you do have your tests next week. So now's a good time to uh, go over anything that you found difficult or want any help with. You guys aware of where to find everything for next week? Nah. Cool. All right, guys. Well, speak to you on Thursday. Have a good couple of days. I'll speak to you then. Thank you. Cheers. How are they giving you the test? On Moodle. So you'll log in on Moodle, download the test, do the test, and then either scan it or send pictures of it back to us to mark it. I think you guys have two. Where can I find this out? Yeah, I think you have two. I'll let you know on Thursday. I'll just double check with Helen. But yeah, so it'll be on Moodle. You also get emailed it as well. So do what you get emailed. Cool. I'll give you some more info on Thursday, but yeah, just check Moodle on Monday. You've got between Monday and Friday to do it, and then we're marking it on Thursday and Friday. If you need any help revising next week, you can get it. But check your emails. You've all had an email from the college about what's going ahead. Cool. All right. Cheers, guys. See you soon.